All right, welcome to the explainer. Now, if you're in DevOps, you basically live inside Linux, right? But have you ever stopped to think about what's really going on under the hood? Today, we're going to build a mental model of the whole system that will, I promise, completely change how you troubleshoot and automate things. So, let's do this. Let's take a single command that you type every day. We're going to follow its entire journey, right from your keyboard deep down into the kernel. And by the end of it, you'll see how this one simple action, it pretty much unpacks the entire philosophy of the whole OS. Okay, so it all kicks off with the shell, your command line. And its very first job before anything else happens is to figure out what program are you even trying to run? And look at this sequence. The shell isn't just randomly guessing where to find SSH. Nope, it's following a super strict, predictable set of steps. It methodically checks a list of approved locations. And that list, it's all defined by one single, absolutely critical environment variable, the path. And this right here, this is exactly why the path is so important. You've all seen that dreaded command not found error, right? Well, that's just the shell giving up because the program's location wasn't in its list. This one little thing is the root cause of so many broken CI/CD pipelines and failing container builds. The system literally just can't find its tools.
All right, let's go a layer deeper. So the shell finds the command. What's next? Well, it hands things off to the kernel, and a brand new process is born.
Now, this little two-step dance of fork and exec, this is the fundamental way that basically all software starts on Linux. I'm not just talking about simple commands. This is how your web server starts, how your database boots up. It's how every single service in a Kubernetes cluster comes to life. And this separation is actually brilliant. It's super efficient because the parent process doesn't need to know anything about the internals of the new program it's kicking off. Okay, so the process is running. But how do we, talk to it, control it? Well, we send it signals. And you can think of it like this. There's a polite way and a not-so-polite way. SIG-term is the polite request. It's like saying, hey, could you please save your work and shut down? But SIG-kill, that's the override. That's stop right now. No questions asked. And knowing when to use which one is absolutely key for things like debugging stuck pods in Kubernetes or making sure your database shuts down cleanly without messing up all your data.
All right, so these processes, they've got to live somewhere, right? They need a place to find their settings and a place to, report back on what they're up to. So let's explore this system's blueprints. These are the key directories every DevOps pro has got to know. Okay, brace yourself for this one. This is a concept that might kind of break your brain a little at first, but it is absolutely central to how the entire Linux file system works. So here it is. In Linux, the file name, it isn't the file's real identity. I know, sounds weird. The name is just a label, a convenience for us humans. The file's true identity is something called an inode. The best way to think of it is like a card catalog entry in an old library. The inode holds all the important info, the metadata, the permissions, who owns it, and most importantly, where the actual data lives on the disk. The file name, that's just the title on the book's spine. It just points you to the real record. And this whole inode idea is what makes links possible. A hard link, that's just a second file name pointing directly to the exact same inode. But a soft link or a symbolic link, that's different. It's more like a shortcut that just points to another file name. And man, understanding this distinction is so critical for managing data, doing backups right, and even getting your head around how things like Docker storage layers work. So think of these directories as your emergency toolkit. When something breaks, and you know it will, this is where you go for the ground truth. You're going to dive into /var/log to read the story of what happened. You'll peek into /proc to get a live x-ray of all the running processes. And you'll check /etc to see the system's configuration blueprints. This is your first stop. Okay, let's talk about the layer that keeps this whole thing from falling apart. Security and control. And guess where the rules are stored? Yep, we're right back to the inode. See, the inode doesn't just know where the file is. It also holds the rule book for who gets to touch it. And every single file, every single directory is governed by this really simple but incredibly powerful system. You've got three things you can do: read, write, or execute. And you've got three types of users who can do them: the owner of the file, the group the file belongs to, and then, well, everybody else. And the chmod command is your key to controlling this whole matrix. You know that permission denied error that drives you crazy when you're trying to run a deployment script? Yeah, 9 times out of 10, it's just because the file is missing that little execute permission. A quick chmod plus X, and boom, you've just transformed a simple text file into a real program the system is actually allowed to run. Okay, so let's tie all of this together, because knowing these fundamentals, this is what takes you from someone who just uses command line tools to someone who really wields them, with precision.
So a beginner might do this. Look for the word error in one specific log file. And hey, it works, right? But it's kind of slow, it's really limited, and it gives you almost no context.
But this is a total game changer. This is how you go in like a surgeon and find problems anywhere in your entire log directory, and you do it fast. You're not just looking in one room anymore. You're scanning the whole building for clues. And the magic is all in these simple little flags. R to search recursively through all the subdirectories, I to make it case insensitive, so it finds error with a big E or a little e, and N to give you the exact line number. These little things, they turn grep from a tiny flashlight into a massive searchlight for hunting down problems.
And this way of thinking, it applies to your whole toolkit. When you really master awk for slicing and dicing logs, or sed for tweaking config files inside a CI pipeline, or using find to automate tasks across tons of files, that right there is the bedrock of really powerful, really reliable automation.
So the path, the life of a process, the inode, and permissions. Look, these aren't just weird, abstract ideas. They are the fundamental building blocks of the entire Linux system. And once you master them, you stop just using Linux and you start truly commanding it. This is the foundation for everything else you're going to build in DevOps.